Alright, on to problem 4, the current source. There are a variety of current sources, but they are all solved in pretty much the same way. I'm given a supply voltage, I'm given a value for the emitter resistance, I'm given a value for the divider resistors, and I'm supposed to find the value of what is the current. So the first thing you should do is follow this hint and find the voltage at the base, that is right at that point. And you do that by using the voltage divider equation applied to the two resistors. So I can just write that the voltage at the base is going to be equal to VCC times the ratio of R2 divided by R1 plus R2, which I can then get to be equal to 15 volts times that R1 or R2 rather is 12K. I'll just leave off the K in the ohms because the units are going to cancel, and then I'll have 12 plus 6.8. And if I hit my calculator and don't screw up the button pressing, we'll have 12 divided by 12 plus 6.8. That gives me 0.63 times 15, or 9.57 volts. So I've got 9.57 volts at the base. Now I happen to know that this is a PNP transistor. So because the little arrow is pointing in, and that means that this point here is going to be 0.6 volts above the base voltage because the current is flowing this way. So I know that VE is going to be equal to VB plus 0.6 volts. And that is going to be 9.57 plus 0.6 is basically going to give me 10.2. Rounding off the 9.57 to 9.6. So I've got 10.2 volts here. I've got 15 volts right there. So the current through the emitter resistor, which is essentially the current that is in the collector, I'm not going to worry about beta because it's a 1/100th down. It is going to be equal to 15 minus 10.2 volts divided by the value of the emitter resistor, which is 625. And so that is going to be, on my calculator, 15, 10.2, subtract, 625, divide, gives me 0.0077 amps, or 7.7 milliamps, which is approximately 8 milliamps. So that's the answer. And that's all there is to that question.